In this video, we're going to cover mean, median, and mode. Now, there's three types of primary measures that we're going to use in statistics: measures of center, measures of position, and measures of spread. Make sure you take notes on all the definitions for these as we move through the unit and any of their notations we're going to learn. Now, measures of center, most of you are quite familiar with the ideas of mean, median, and mode. They all three describe what's happening in the center of your data and what's typical in that graph. The first one of the three we're going to look at is a mean. And we also can call it an arithmetic mean, or in plain English, what we actually use the most is the word average. Now, what's new and quite important is that you know what notation we also use for mean. Mean can be either represented by x bar or mu. Mu is what we use when we're describing the mean of a population set of data, and x bar is what we use when we're describing the sample mean. And the math is the same for both of them. It's just we use the different letters to represent what kind of data we collected, if we collected it from everyone or just some of the people from our interest group. Now, mu is just an upside down H, and it's a Greek letter. Anytime we use Greek letters, we're going to know it's a population, versus every time we use lowercase letters or just plain English letters, those are sample. So if you see in the population mean formula, we have Greek letter and a capital N. That all tells us it is a population. So in the top of both of these formulas have this E looking thing, which is just sigma. And again, it's Greek. But what that represents, and that's going to be used a lot in this unit and moving forward, is the sum of. So that's all that means, the sum of all of my x values, all of my data values. So both of these formulas are done the same. You add up all the numbers, the sum of all the numbers, and divide by how many you have. Big N just indicates the number of numbers you have in the population that you collected, and little n indicates the number of the sample that you have. Now, with mean and all the other calculations we're going to do moving forward, you have to keep track of rounding. When you're rounding, you have to, if you're deciding to round at a certain place, you have to decide if it stays or if it rounds up, and it just depends what it's followed by. If it's followed by 5 or greater than, you round up. If it's followed by a number that's less than 5, you round down. Now let's consider these examples, and make sure if you do not know these decimal places and what they're called. So tenths, hundredths, thousands, anything with THS at the end indicates it's after the decimal place. So let's consider the number 4,827. If I was rounding it to the nearest 10, that would be the 2. I would try to decide, is the 2 going to round up or down? So one way you can think about this is 27. Is that closer to the number above it or below it? Well, it's above it, so I would round up. So the 2, the 7, afterwards decide if I round up. Same thing if I round to the nearest hundredth, that would be 8. The number after it, it's smaller than 5, so I would just leave the 8 alone, which would leave it as 48,000. If I was trying to take the same number and round it to the nearest 1,000, 1,000 is right here, it's at the 4, so I decide to look at the number afterwards. 8 is bigger than 5, or equal to, but in this case bigger, so then that makes this 4 round up, which would make it 5,000. Try these three problems. Hopefully you have gotten them right. If not, please ask your teacher for help on rounding. Now, same thing with the decimal place. You just need to look at the number that's after. So if I'm rounding to the nearest tenth, I look at the number afterwards. 1 is smaller than 5, so it just stays as 7.8. Now, how do you decide how many decimal places to use? You're not going to need anyone to tell you. You're always going to need one more decimal place than the original data values. So if my original data values had no decimal places, then my calculations would need to have one decimal place. And let's look at an example of mean for cockroaches and their lengths that are found in a teacher's lounge in centimeters. Now this is most likely a sample, so I would need to put X bar at the beginning and just add all the lengths and divide how many cockroaches I sampled, and notice my mean has 2 decimal places since my original data had 1, and I should put centimeters at the end, and that is it for mean. The median is the middle value, and the one thing you have to be careful about is that your numbers are in order, and if there's just one middle number, you're fine, you're done, but if there's 2 middle numbers, you have to find their mean or average. So let's look at such a special example. So same example with the cockroaches, you'll see there's 12 numbers, and when we put them in order, and we start crossing the numbers out to find the 2 middle numbers in the middle, we are left with 3.4 and 3.8, and to find the median, we have to find the average of the 2 middle numbers, which would give us 3.6. Now the reason we only have 1 decimal place here, even though our original data had 1 decimal place, is because 7.2 divided by 2 divides exactly into 3.6. So we do not need to add decimals if there's not any more afterwards. We just need to be careful with rounding. Now mode is just the value that occurs the most often, so it shows up the most. And you can have more than one mode, and we would call it bimodal, and if there's more than 2 modes, we would call it multimodal. And this, out of our measures of central tendency, the mode is the only one that can be used for qualitative or catechol data, as in what's your favorite color. Whichever color would be the most often would be your mode. But you cannot do calculations on favorite color. Now, if we were to look at graphically, unimodal would just be 1 highest peak, bimodal would be 2 equal highest peaks, and multimodal would be 3 equally high peaks, or more than that. Multimodal rarely occurs with real data. And if we're looking at this data value, we see that the number that occurs the most is just 3.8. And that's all you have to do. Now, even though they're all measures of center, they don't all have the same number because we calculate them differently. And hopefully you saw that in the previous example. Now, what does that mean for our data? Well, when there's an outlier will affect certain numbers, certain measures of center more than others. So if you looked at our previous examples, you would have noticed that 12.1 was one of the numbers. Now that's clearly an outlier, and an outlier is just something that stands out from the rest of the data. We'll learn how to calculate that more thoroughly and mathematically, but for right now we'll just approximate what the outlier is. So 12.1, if we were to remove that, you would notice that the mean is now 3.5 and it started as 4.22. The median, now 3.4 is the actual median, and before it was the average of these 2 numbers, which would be 3.6, and that has decreased. So the median has decreased just slightly versus the mean has decreased drastically. And the mode did not change, it's still 3.8, which hopefully makes common sense to you because mode is the number that occurs the most, while an outlier is something that stands out and is different from the rest. Now, this will always be the case. The mean will always be affected and pulled towards the outlier the most, and the median will be slightly affected, but only a little bit because it's only 1 number off, and the mode should not be affected at all. Now, if you look at mean, median, and mode in shapes, there's 4 main shapes we're going to discuss. Approximately symmetric and approximately uniform will look kind of like these. These are actually perfectly symmetric and perfectly uniform. However, most of the time they won't be this perfect. So approximately symmetric just means that what's happening to the left is happening to the right, and there's like an imaginary symmetry in the middle of the graph, versus uniform just means that they approximately have the same height for all of your of values. Now, this does not have any modes. Uniform has no modes. However, the mean and the median would be approximately in the middle and equal. Same thing with approximately symmetric. The mode and median and mean, all three of our measures of center would be right in the middle because it's approximately symmetric and there's no outlier to pull it towards one direction or another. The next two shapes we're going to consider are skewed right and skewed left. Now, these are the two most common mistakes that you will mix these two graphs up. When you determine which way a graph is skewed, if it's right or left, you have to look sort of for that tail. So if you see, most of my data here is to the left, but there's a tail to the right. So you want to look at the tail. The tail tells you which way the graph is skewed. So this tail is skewed right, and this tail is skewed left. Now, tails act just like outliers on our data, and our tails will pull my mean away because it's much, much stronger. So if I have a set, my mode would most likely be here 5, and in this one would be 13, versus my median would be slightly affected and would be closer to like 6 or 7, and then my mean is the one that's most affected by outliers or tails, and it would be the one that would be most towards the right and towards the tail. Same thing here. My median would be a little more to the left of the median. So, and then my mean would be even more towards the tail. So just make sure you write this down for how things are affected by skewedness or outliers. Now, let's look at this example and try to calculate the mean and median, as well as the mode. Hopefully you've calculated the mean and the median to these values. And we can say some conclusion about our shape is that since the mean and the median are similar, very close together, the difference is only 0.4, that the shape is most likely symmetric. So that the mean and the median would most likely be close together and towards the center of our data. Now, if you actually look at the data closely, you'll notice that there's an outlier. And our outlier of 56 should be removed so we can kind of get a better idea of what's actually happening to my data. Calculate the mean and median without the 56 and try to see what does it tell me about my shape now. So my mean and median haven't changed quite as much, so I would still probably say it's symmetric. But both values did change, but notice the mean did get affected more by the outlier. It changed from 25.9 to 24.5 versus the median only changed by 0.5. Keep in mind though that if your mean and median are similar in values, then it's probably approximately symmetric. However, if your mean is greater than your median, that means that the mean has been pulled towards the right, which would make it skewed right. And if your mean is less than your median, then your mean has been pulled towards this side of the number line, which would make it skewed left towards your tail. Now, how do you decide which of the values do you really need to use to describe it? Well, we use mean when it's not really affected by any outliers or tails. So we would use it when it's not skewed. And we use median when it is skewed. Which measure do you think would be best used here, and why? I would personally choose median because we have our data, there's tails and probably outliers all the way here. So that would pull my mean very much along towards there. And therefore I would choose the median to kind of describe where my center of this graph is. Good luck, and let's practice mean, median, and mode and shapes.